class, I have discussed about single linked list and the concept of doubly linked list, and just a one-liner statement that what about the circular list and all. So today, first thing that we will do, that is represent use means doing polynomial operation using the linked list, how the polynomials are actually can be represented using linked list, that I will discuss. Next, we'll discuss about circular linked list, and then I will give you set of problems which are a little bit tricky over the linked list. You need to think, you need to tell me the way out, and then we will discuss the solutions. Okay. As of now, this is the plan. Now let's see. If time permits, then only we can go for some other topic. But as of now, this is the plan. Now, in the various subjects, we deal with the polynomials. What does it mean by polynomial? Now, definitely polynomial or where we use all these things or anything. Now, we use in the function representation, a mathematical function representation. What we called as a polynomial? The power. If power of x in any expression is more than 1, then only we think about that it's a polynomial. Means if it is only y equals to 5x plus 3d 3, then it's not polynomial. You may consider it's okay. The power is 1, the power of x is 1. But if it is 5x square plus 6, it's a polynomial. If it is 5x square plus 6x plus 8, that's a polynomial. Okay. So this is just 2 examples I have taken. One is 5x square plus 4x plus 2. This is your first expression is your just 5x square plus 4x plus 2. I hope you can remember that something to the power 0 means that would be considered as 1. So first expression is your 5x square plus 4 to the power x and then 2. And second expression in the similar way is your 5x plus 5. Now, obviously, here what we want to do, we want to do one addition. We want to do a simple addition. So, I hope all of you know the addition, doing addition of normal polynomials or anything. So, if I want to write it, this will be 5x square plus 9x plus 7. So that is your outcome supposed to be. Now, how we can represent it? Another example is being taken with 5x cube, x square and all those things. So we will now learn that how to use, means if I say this is your this and this, how we can represent this expression in the linked list or any other data structure, and how we can perform the additions of all this. Now, the linked list representation of a polynomial is like this: coefficient, power, address of the next node. So if you can remember the normal structure of the single linked list, where only one part will be there for link, and we have used one part for data. And I had mentioned at the beginning of the class, in the last class, that I am using one data, but that doesn't mean there will be always one data. It may be any number of. So here, the first thing is your coefficient and second is power. See, what is my expression? My expression is 5x squared plus 4x plus 2. See, 5 is here. Yeah, no x to be written. What is written here? The 2. This part is containing the address of this node. And the second node is 4. X to the power, this is 1. So 1 is written here. And then 2, then the 0. Because x to the power 0 means 1. So this is the linked list representation of this polynomial. Now, what you want to do now? Add the next expression is 5x plus 5. So this is another expression, and this way the linked list can be represented. Now, the point is that how we can do the addition, subtraction, or any other operations. See, multiplication, division will become very much complicated. Anyway, let me just discuss how things are supposed to be done. If you understand one operation, you can do the rest of the things. Whenever we want to add this kind of expression, 5x squared, 4x plus 2, 5x plus 5, how we add? In a normal addition, we do the addition in just number by number, means if it is any number, you can add 1011, then 11, you will do the addition this way. But here, how you will do? Now here the rule is that you need to check for which coefficient the power of x is same. For which coefficient power of x is same. Fine. So you cannot, this is very easy when you are just looking at this and you are writing the answer, but you need to implement it in the linked list program. So you need to start from the beginning of both the list, and then you need to traverse. You need to traverse from the start node to the end of the node in both the list. And whenever you will find that this power part is same, then only you will add the coefficient. So if I consider this first list with the second list, what I will find? Now, for the first node, you will get that, okay, there is x square. You need to check whether the square term exists here or not. If exists, then only you will do the summation. If not exist, you will just proceed. That means if I want to do the polynomial addition or any operation related to polynomial, it's not mandate that both the lists should be of equal length. Both the lists should have same type of power distribution. No, not necessarily. So you need to check this one. Something exists? No. So proceed. Then when you will get this one, it is matching with this, you will just check, and then only you will do the addition of the coefficient. As you are doing the addition, there is no meaning to add the powers. If you do the multiplication, then you need to add the powers maybe. But here you are not supposed to do that. Similarly, again go forward and again check the power. Fine. And then add the coefficient. This is just the discussion, how we can do that. See the structure of the node where one parameter is for the coefficient, another parameter is for the power. I have already shown you the node structure. One part is for coefficient and another part is for power. And here, as we are going to deal with two different polynomials at least for the addition. So you need to take two different lists for two different polynomials and one for the resultant list. So start 1, start 2 and start 3 are being taken for the same purpose and all of them are initialized with the null. The node creation is same, only the part that in the previous programs we have assigned a single data name member, and here you need to take the input for the coefficient and power both, and you need to assign accordingly. And then for the newly created link, things will be null. Means this is doing what? This is just taking first this expression. This particular line is allocating a chunk of space. This line is taking one space for n. This line is taking one for the C, and then the new link is now. So this is your node creation step. So create the node in this way. Now, when you will going for the addition, what are the different situations or conditions may arise? Powers are equal. That is your happy situation. That yes, if powers are equal, I can directly do the summation and all those things, or the subtraction, whatever is required to. One power is greater than. See, one expression may be there which is having one square term, one cube term, one means 5x cube, one x, only x to the power 1, this two term, and another term you are getting maybe which is say 1 x to the power 4 term and 1 x to the power 2 and 1 x to the power 0. Then how we will manage? Now that is, there may be situations when power greater than another expression. I mean, in one expression, whatever the x is power, in another expression, it may be something else. Power is less than, okay, fine, that is also possible. Or one of the list is completely empty. So these are the different situations that we need to think before we go for this polynomial operations using linked list. Now, easiest part is if powers are equal. What you need to do? You need to take two pointed variables which will start with start 1 and start 2, and till the list exists, ptr 1 not equals to null and ptr 2 not equals to null means still the list exists. What you need to do? You need to check whether the powers are equal or not. Two lists are there. You have started from a beginning. You just proceed, and while you are proceeding, you are checking the power of the coefficient node by node. Since the last expression 1 is with x square, but in the second expression there is no square term. So that means initially the start 1 and start 2 both are pointing to the beginning of the list. So for list 1 it is pointing to the x square term, but for list 2 it is pointing to the x to the power 1 term. So definitely you are taking the first node power So things will be result in a no, because the power is not same. So if equal, then what you will do? Then sum equals to addition of the coefficient for both the list. And you should call this add node function. What is the purpose of add node function? Now, this is actually making the final list for the result. This is making the final list for the result. So start 3 is being taken for the result. So add node means adding a node to the empty list. So start 3 is the starting pointer. You call the function. This is obviously a user defined function, no library function it is. Then the result of the summation and this power. Now, why I'm taking this particular power? First of all, even I take PTR2 power, that is not at all a problem. But normally we take this one. As equal, you can take any. Then, so for the first node or the node for which the powers are matching, job is done. Next, the next step is both of the pointers should be incremented. Both of the pointer now should point to the next node. So use this step. Right. Now, powers are not equal. That is the quite common case even in our example that we have taken initially. To call the function with PTR1 coefficient. Why? If you see this one, x square, okay. So at this position, nothing is there, but it's not position wise, this is the beginning. So if you check this is as the beginning, well, you will find x is 1. So PTR1 power, which is 2, is greater than PTR2 power. But in the result, that means I need to take the x square term first. So start 3 is the starting point of that list. PTR1 coefficient. So this will go. And PTR1 power. So this will go. Because in the resultant, you need to write the 5x square. It's not like that if the powers are not matching, then you need to, no need to perform the addition. No, it's nothing like that. It's only that you need to take that particular element which is of this type of thing, where the power of x or first list is greater than in the second list. Then you and see, as you have taken this particular element of the first list which is pointed by the PTR1, so only PTR will be implemented, not the PTR2. The PTR2 will be pointing to this location. Okay. Next step. If the reverse thing is true, that PTR2 power is greater than PTR1 power, then the reverse thing you should do. You should start 3, PTR2 coefficient, PTR2 power, and you should increment only this one. If any of the list is empty, means empty means there no list exists. So when we have started the program, someone is making continuously noise. I am giving you the opportunity to say something if you do not have any query, if you have any query or anything, but continuously you are making the noise. Mute yourself now. Again, I have to do that mute all and all. So next, so if ptr 1 equals to null means if that there is no first list, then everything that is exist in the second list, use them for a final outcome. Means if the input is only 5x plus 5, first one is just null, and you are getting this, okay, if this one, but this is exist, then the result will be 5x plus 5 only. Similarly, if the reverse thing, that second list is null, but the first list exists, then take everything from the first list. So this is just the thing, how we can deal with the polynomials. See, this way things has to be understood. Now, the point is, if it is subtraction, obviously things will be same. If it is multiplication, no, things will not be exactly same. Things will be little bit complicated, because whenever we do the multiplication, say you have one 2x plus 5 and another one is 2x square plus 6. So you know that each of the terms supposed to get multiplied, right? Means if you have a plus b and multiplied into c plus d, what we do? This will be a into c plus a into d plus b into c plus b into d. So here means you have to do the multiplication of this. So this will be 2x into 2x square. So that means while you are writing the program, this comparison of power is not required. What you will do? You take each and individual node of a list, any of the list, and you need to do the multiplication of the entire list. And then you recreate, you just going on creating this kind of that add node function and continuously add the values there, right? Once for the 2x, 2 into 2x into 2, and whenever you are doing the multiplication, what we know that if I do the multiplication, these indices must be added. So if I need to do the multiplication, I will multiply the coefficient and I will add this power of x. I know you know all these things, but maybe you have forgot because of lack of practice. So I'm just giving, and then you will proceed. There is no such checking that where is one power is more, one power is less or not. Fine. Now, if it is a division, things will be much more complicated. You need to take the example, you need to understand how normally the division works, means how the coefficient or how the power. So obviously the power is supposed to be subtracted in case of division. And when number is divisible by or not, also that depends on the power. So you need to deal with the example, then only you can understand. But this is the way we deal with the polynomials. Okay. So if you have any question regarding the polynomial addition, you may put forward. And after that, we will go for circular linked list, and then we will go for the different categories of the questions. So if you have any query, I'm allowing you to unmute yourself if you want. But if you do not want, please keep mute yourself. If you want to ask something, you may ask. Otherwise, I will go for circular. I'm discussing the circular because after this circular, the problem statements that I will give you, those actually require lots of effort. Means unless until the you will just brush up the circular linked list memory, maybe it's not possible for you to think that what may be the answers or how you can find the answer. Okay, so I'm not getting any query. Maybe you have done it all. So now in the circular linked list, what is the concept? The concept is that first thing, that it can be your single, it can be double. And as I had discussed in the last class, that in any case, the single link, dealing with single linked list is much easier than dealing with the doubly linked list. So what is there? Now this is your list. You can see that the first node is having the address of the second node. The second node is having the address of the third node. Third node is having the address of the fourth node, but the fourth node, which is the end, is actually containing the address of the start. In case of circular linked list, we will not find the null. See, if in a list there is no null, you can say that, okay, that can be considered as circular list. Node definition, if I use the if you go for the node definition of the circular linked list, that is very similar to the single linked list, because circular linked list is not having any other speciality other than the last node is having the address of the start node instead of now. So there is no special thing about the node definition. That is very similar. In the creation, what we will do? Now in the creation also, you just need to take normal, the new node pointer and the supporting pointer P. You need to create the function if start equals to null. Now you can say, ma'am, just few minutes back you tell us that there will be no null. But if there is a list exist, then only there is the situation of no null. But whether a list is already present or not, that you can check with this start equals to null. Because at the beginning, we all need to assign a pointer start as a null, because we consider that this start is the starting point or the head point of a linked list. Okay, so if start equals to null, then the same thing that you have done in the single linked list, new node link equals to new node and start equals to new node. See, where is the difference? Previously, whenever we have created any new node, what we have done? Now we have, let me take the pen. We have done what? We have created one chunk, then one data part, and we have done this. in the single linked list. But see what is being done here. The new node is being created, and then this n is being assigned, but new node link is being assigned to itself. So it's not like that you create the entire list and then you just take last node link and you will connect it to the start. This operation is started from the very beginning. Okay, that's why I'm telling that if a circular linked list exists, there is no chance that there will be a null. So null is never being assigned to the link of any circular linked list node. This new link means new node address part is assigned with the self address. And then you are making this node as your start. Fine. Okay. So this is for the first node. If I want to do, or if I want to add the next set of nodes, obviously I need to do that. So again, take the help of this temporal variable p with the start. While p link not equals to start. In the previous thing, what you have checked, p link not equals to null. But here, no question of null. So you need to go to the start. For start is this node, and that is so. This is your means. If I consider the list, this will be obviously connected to this kind of thing. So this is your start node. So it will check whether it is pointing to the start or not. Till it is reaching to the start again, you need to traverse. So once your traversing is done, how you will traverse? Now p equals to p arrow link. This way you will traverse. Then p link equals to node. So when it will be a new node is being created. If there is a new node that is see here, your new node is being created anywhere. So what it will do? Now it will reach to the starting point and then understand, okay, so here is the point where I need to add. So it will do what? Now it will do the p arrow link, because this is your p. So p arrow link will be added to here, the new node. And then new node link will go to the start. So if you really want to understand the linked list, many a times, even when you were in the second year, I had explained that you need to draw the things. Once you can draw, you can understand. So this way you need to add the node, or this way you can create the node in a circular linked list, or this way you can create the entire list. Okay. And again, like the single linked list program, I'm taking again the scanf value and all, so that the moment n will become -1, the entire loop will stop. It's just a stopping criteria. And now if I want to display, again I need to start from the start, p link not equals to start, and repeat all the data. Now you can remember in the single linked list, we have used here p not equals to null. But it's not required here, because here it is moving in a circular fashion. So if I check whether the link is start or not, it will reach till the end of the list. Now suppose I want to add a new node. How I can do that? This way I can do, I have already explained. So at the beginning, if I want to insert, again I need to traverse. I need to create the node, and I need to traverse. I need to traverse till I am reaching the start. So when I am reaching till the start, that means at that end I want to add the node. So again the p-link arrow will be given to new node, and new node link will be the start. So this is the insertion at beginning, is same as your creation of the list. Similarly, if I want to do the addition or at the end of the list, again the things will be same. The address of new node will be assigned obviously with the new node, and new node link will be assigned with the start. So whether it is beginning, whether it is end, whether it is creation, things will be same always. Things will be same always. Now, if I want to add at any position, so for that what you need to do, you need to know from the other person that where you need to take the input where you want to insert, maybe this position. So from the start until the link is not ending the end, which is nothing but the start, you go and then you check for each node whether that is matching with this m data or not. If they are matching, then you just take P arrow link, Q equals to P arrow link. Means you are traversing the thing. Then you just go for, once you, means the moment you are finding the match, then you, means this is like this, let me draw this. So you need to find, suppose here the data M is present, okay. So then what you are storing, Q equals to P arrow link. This is your P. This is just a simple variable, Q equals to P arrow link. What is the content? Now this is, what is actually now this? Actually Q is containing the address of this node. And then you are want to insert the node at this position. So you are making P link. You have assigned the address of the next node to the Q. So Q is actually holding the address of this node. So P is pointing to this, and then this new node should point to the Q. This link already been discarded. So this is the thing that you need to do. So where is the difference with normal simple single linked list? Almost no difference, and just a difference with the start and the null. Initially in the single linked list, you check for the null as an end, but here you will check for the start point only. Rest of the things are same. Similarly, if you go for the deletion, you need to traverse, and then means if this is the list, if you want to delete this node, that is the beginning, then this link has to be made with the this one. What is this now? That is start link. So make the link, make the node p link to here, and call the free function to release the space. Deletion from the end, again the same thing. You should check where is the end. So end, beginning, all the same thing, but in the beginning you are deleting the starting node, and here you will deleting the last node, means just before the start node. In Rodil, you can place your query, you no need to raise the hand. Anyone can place their query. Tell what is your query? What is your query? Is there any query? I'm not getting any answer.
Ma'am, we really need to free the p variable, means the data stored in p.
I don't understand your question. Repeat, please.
The last line where it's written a free.
Oh, if
free
I don't do the free function call, it may not create problem, but actually if I do not call the free function, all the garbages will be stored in the memory as it is. In the linked list deletion, we are doing what? We are just making a node isolated, disconnected, not actually freeing of the memory. By the rest part of the code, we do not do the deallocation of the memory. So with the free function, we are actually deallocating. Because rest of the part of the code, what we are doing, we are just ensuring that this node will become isolated. No other node will have any access to it. Means if we do not deallocate, then main memory will be full of garbage. Anything else? So is it clear to you? Yes, no, respond. Na, otherwise how I can understand? Is it clear to you?
Yes, ma'am. Yes.
Okay, fine. Now, if I want to end it, means if I want to delete it from the end, see, when I am deleting, when I'm trying to delete it from the beginning, that's a different thing. Different thing means I want to, whatever the starting node is there, I want to delete that only. But now, when I'm trying to delete from the end, so what this is one node, 2, 3, let's say 4, and this is connected this. So when I want to delete the starting node, this was this. But now I want to delete the end node. So the node which is before the start, I want to delete. Okay. So you traverse the list till the link is start. Now you never know the length of the list. You never know where is the end, because you need to delete the end. And you can identify the end when the link part of this main end node is again the starting. So p link equals to start, not equals to start. This way you are traversing. And continuously, like other linked list program, you need to change or you need to keep a track. So whenever P is moving to the next node, say this is your P, whenever P is moving to the next node, this address is assigned to Q. So this will be continued. Again, this will be Q, this will be P. Again, this will be Q, this will be P. And now, not equals to start, this particular thing will not hold. That means it is identified as the end of this circular linked list. Means last node. So what you will do? What you need to do? You need to delete. You need to delete this particular node. You need to delete this. So that means this link has to be made here. So what is that? Now that is basically P link. So you can link the Q node. the node Q with the address part of P-link, whatever the address is there. So you are moving. So you say if I slide start, will it work? Yes, it will work. Because that is basically the starting point of the list. So this way you can delete something from the end. Now if I go for the double circular list, things will be a little more complicated, as for any kind of pointer manipulation, you need to deal with double set of pointers. So you can see here, every node is connected with double connectivity. And that's true for the entire list. So you can see here that the first node is connected to the last, and last node is connected to the first also. In the previous one, so much connections were not there. Okay. So whenever you need to deal with now, the doubly linked list node creation remains same. The data part, the prev and next to connecting to the new part. See, in the normal doubly linked list node, if we arbitrarily create a node, what we do? Now we assign the null. We assigning the null to the prev and next for the first time creation. And here, both the things that I have shown you in the time of single linked list implementation of doubly linked list, that time you are pointing to the one node. The link part is pointing to the only one node, that is the new node. Here, prev and next, both will be pointing to the node itself. Okay. So that things will maintain that circular format. Similarly, when you will create a new node, so again the start will be compared, start will become the new node. Else you traverse the list, and what you will do here, suppose a list is there. This way things are going on. So now here, if you want to add a new node, so what you need to do, you need to make a next connection to here. For this node, the previous connection should go here. For this node, the next should go here, and the previous should go here. These links are not to be used. So what it's being done, new node prev. So this particular line is for new node prev. Is what? The P. Okay, because this is the point where you want to do the job. Or if you say, see, this is in between. But if I want to do here anything, so as you are going to the end, suppose you want to add the node here. This is for the normal creation. So you may want to add maybe that the end. So for this node, the prev must be connected to this. For this node, the next must be connected to this. This is your new node. Previously, this node end is connected to the link, but for now, this will be connected to the this. And for start prev, this will be the previous connection, that is this one. This connection also will be connected to this. Now, if you want to insert anywhere, the anywhere insertion actually doesn't impact have any impact over the entire list creation. Just manipulation of these links are important. So in case of circular linked list, be it single or double, what we can understand? Now we can understand that if I want to add or delete from beginning or the end, then only we need to think more. But if I do something within the list, we don't need to think that more. So similarly, insert at beginning where you are doing new node prev equals to P, because P is the last node before the start. So link there. Then P next equals to new node. That is also okay. New node next equals to start, and start prev equals to new node. So these, all the lines and the sequence are very much important. If the sequence are not being maintained properly, you may lose the entire list. And if you lose the control of entire list, it will not give you any error, just you will not get your desirable output. Similarly, if I want to add something at the end, so for the end, again, how you can identify it? Now for that node, the next part is start. Start is connected as a next link. So the new node next should be connected to the start. Fine. New node prev should be connected to that P where the previously the next link is connected to the start. So new node prev will be connected to the P. P next will be connected to the new node. New node next start, and start previous new node. So you can see if you need to implement it with doubly linked list, you need to deal with a lots of link. Okay. So be careful if you are using that. Similarly, for deletion, if you want to delete from the beginning, that is the starting node, the same thing, you need to find the start node first, and then that must be pointed to the very next of that node. And for start next, that is the next node, the second node of the list. From there, prev equals to P means P is what? P is the node which is having the link to the start node. So that is the node before the starting node. So start next prev means the second node prev connection is to be made with P. And then start equals to start next. Then you are supposed to free the memory, free queue. If you want to end, if you want to delete something from end, so now the point is that what you need to do, now the point is that whatever is my last node, I need to delete that. So whatever is node is the previous of the last node, I need to make the connection of that node with the start. So see here, like the normal linked list program, one tracker is always there. So Q is the node. Q is pointing to the last node basically. P equals to P next. At some time, it will point to the start. So Q next. Q is that last previous to the last node. So Q next will point to the start. Start prev will point to the Q. So the moment you made this kind of link, the middle one, the P, obviously automatically disappears. So this is deletion from end, and this is about circular linked list. Now I will share a set of interesting questions. Only questions are there, obviously. You need to find the solutions. At least you need to think. I'm giving you first few minutes of time, and you need to think the answer for all of them one by one.
Recording stopped.
No MCQ, nothing. These are directly questions, but very interesting, because last day I can remember, I hope that particular person is present in the class, who was, firstly he was talking about the linked list but end up with a string problem. Anyway, that's not an issue. So
Recording in progress.
these are the typical problems. I hope you can see. These are the typical problems which needs a little bit of thought process. These are the questions. These 6 questions are there. Yes, I am giving you, say, 15 minutes of time to think what can be the solutions or how you can solve this. In this 15 minutes, obviously, I'm not going to help you for the solution. You need to think and you need to find the solution. Maybe to some of them who are doing regular practices, this kind of problems are known to them. Start solving. You may, in your copy, think about the algorithm and try to find the solution in this way. After means it's 10:03, so after a certain time I will discuss all this. Just a second.
Recording stopped.
Okay, so if you have any query regarding the question, you may ask, not about the solutions. I will discuss one by one solution. But first, I want to listen from you, but from maybe after 10:15, I will ask from you. But before that, you just think and think. Circle means it's a loop. Because whatever you understand as a circle, circle means circle, circular format. It is making a loop or circle. It's a round, something round. You no need to write any solution in the chat box, please. You can unmute yourself and we will discuss one by one solution. I told that those who are very much frequently solving this kind of problem, they knew all the answers, but not for all, that's not common. So do not need to write anything in the chat. We can discuss one by one solution. 2-3 minutes more, then we will discuss one by one solution. That how you can find the solution for each of them, we can discuss that. Yeah, turtle. It's okay. You know the answer, but still the answer that you have written, the original point is missing. From your answer, if one try to do the program, obviously will not get the answer. Okay, so do not write any solution in the chat. Okay, so you can unmute yourself, and if you have any suggestion before I start discussing one by one, any one of you, if you want to say, we will start with the problem statement 1. Are no need to get any kind of attendance in the chat. Don't think that these attendance are being taken. The attendance is taken from the Zoom report only. You no need to write all these things. You don't listen. Actually, you don't attend the class. You think that you just write a chat one time the attendance and that will be sufficient. The entire attendance is taken from the Zoom report. And let me
Recording in progress.
So now I will discuss one by one problem, and if you have any suggestion, I will listen to your solution also. So for the first problem, it asks us that we need to check whether a linked list is null terminated or ends in a cycle or not. So that means it's like this, that say this is your list. You need to check whether a circle exists or not. So yes, the person who have written tortoise and all those things, it's okay. That means that particular person knew the answers. But for others, I'm asking that if you have any suggestion, any solution, you can unmute yourself and you can tell. You can unmute yourself and you can tell. Anyone? There is no response from your side. It seems that we are studying by ourselves by sharing the screen. See, a few minutes back, when we have discussed about the circular linked list, what we have understood that circular linked list is something where starting point and ending point is almost same, where no null exists. So what we can do now, we can start from the beginning and we can traverse, and every time whenever the next node we are getting, we need to check whether it is similar to any other previous node or not. Right? That is the easiest approach, that from the first node you start and there is any node, whether for any node, whether the next pointer is current node address or not. If there is a node with same address, then that indicates that some other node is pointing to the current node and we can say the loop exists. For any next, if it is pointing to the previous node's address, you can say the loop exists. But for that approach, you need to store the address of individual nodes. Are you understanding what I am telling? That the brute force or the normal approach is that you start from the beginning. Every time you are going for a next node, you need to check that this next node address, whether that is similar to any of the previous node, or maybe that particular node or anything. Means suppose if one circle is there, means one, this is making circle. So you need to check every time the next part with this one. But do you think that that is a very good source? So for that, you need to keep the address of each node somewhere in some list or anything, and every time you go forward, you need to do the comparison and all. No null exists, we can say circle exists. So you want to traverse, but how you can say that Where you, how you can stop? No null exists. Yes, I agreed to the point that if no null exists, I can say the circle exists. Fine. But how you can conclude? If I want to check for the null, it will go in a infinite way. So how you can ensure? You are going for a checking, this will check, it will come here, it will move around this, it will again come here, again it will go in this way, continuously it will moving around. So how your operations can ensure that yes, there is a circle? It may go into infinite loop. If you do not find any kind of stopping point, you will go on with the same thing, right? Then no null, cycle exists, okay, but how you can do it? It's not possible with that. That simple concept is not sufficient. Another thing that I told, that you can store all the addresses. Whenever you are visiting a node address, that store the address of that node in a list, and every time whenever the next address you are getting, you may check. If address of any node is equal to the last node, you never know that which one is the last node. The circle need not to be at the end. It may be anywhere, no? It may be anywhere. But in any case, you need to check whether things are matching or not, whether things are working or not. You never know where is the last node. You don't have that idea also. You need to keep the track of all the nodes. But that requires a extra memory, extra array and all, so that's not feasible. One solution is there with two different pointer concept. For this kind of problem, these are the standard problem of linked list. One slow pointer and one fast pointer is being used. With the help of these two pointers, we can identify that whether a circle exists or not. What is the significance of these two pointers? Now, slow pointer is by nature slow. It will move one position at a time. Fast pointer will move two position at a time. So what it will do? Initially, I'm writing only S and F. Both are in the beginning of the list. Now in the next iteration, S will move to the second and F will move to. So start next. So F will come here. The idea is that if they are meeting, as their speed is different, they are not supposed to be at the same pace. But if there is a cycle, then they are expected to meet if there is a loop. If there is a loop of this kind of cycle, then they are expected to meet. Now, how that is possible? Let us see. So F again will go here. S will come here. Okay. F again will come here. S will go here. F will come here. S will go here. F will go here. So it says if slow and fast pointer meets, then there is a loop. This is a standard approach of efficient solution. This is a standard approach of efficient solution. It's not very critical or anything. The persons for whom these are, if you do the regular practices of linked list program, the means any kind of critical program or tricky program. These are not critical, these are tricky. So how the things will be there? Now initially the slow pointer should be, these are all struck node kind of pointer. Fast pointer. Okay. Initialize them, both of them. This is also initialized with head. This is also, I mean, head or start, whatever you can write. Head. Then they will move. They will move continuously. Okay. How they will move? The inside a loop, definitely. This means both are having some node value and fast pointer next is also having a non-null value, because all these are ANDed. This is one and this is one and is given. So I'm taking slow pointer is not null. First pointer is not null. First pointer next is also not null. Okay. And these all are ANDed. These all are ANDed. So if any one is null, then the loop will stop working. So obviously, if there is a cycle, there is no chance of null. So that means it will move infinitely until it can get that checking point when slow pointer and fast pointer is same. So how we may proceed? Till anything is not null, so we can move slow pointer will be slow pointer arrow next, fast pointer equals to fast pointer next, comma next. Okay. Slow pointer to the next, so 1 point, fast pointer next to next. Now, what is the criteria? If slow pointer equals to fast pointer, then only it will break. And you may give some return statement like 1 or anything, and further you may check, or else you may go for returns. So this kind of thing, I'm just writing the basic lines that will be required to understand that how we may proceed or anything. This is the point. This is the most efficient way of solving this. So this way, if the cycle exists, we can go for this kind of solution. I hope the solution is clear to you. I hope the solution is clear to you.
ম্যাম এখানে যদি কোনো নাল পয়েন্টও থাকতো তাহলে এসআরএফ এর ভ্যালুটা কখনো ইকুয়াল হতো না।
It's a cycle. How the null will exist? If the null exists, the loop will stop performing. Isn't it? If any of the
Yes,
pointer,
ma'am.
right? So if a null pointer exists, then the loop will stop performing. Right? So this way we can solve whether a cycle exists in a list or not. Fine. Okay. So this is the discussion of the first one. Now I want to listen from you what can be the solution for the second one. The second one is again pretty easy. It says not easy maybe. If linked list is having a circle, if linked list is having a circle, then find the starting point of the loop. Yes, follow.
ম্যাম আমার একটা থিওরি আছে, ফার্স্ট কোশ্চেনটার জন্যই আমি ভাবলাম আমাদের কোশ্চেনটাতে ছিল হয় check whether a given linked list is either non-terminated or ends in a circle. তো ওটাকে যদি আমি এরকম ভাবে মানে প্রত্যেকটা নোডকে যদি আমি রিভার্স করতে থাকি, মানে লিস্টটাকে রিভার্স করছি, তাহলে রিভার্স করতে করতে জিনিসটা এরকম হবে যে ফার্স্ট নোডে চলে যাবে যদি যদি সার্কেল থাকে, আর যদি সার্কুলার না থাকে তাহলে আমি নরমাল রিচ করব।
তুমি বুঝতেই পারছো না, সাইকেলটা তো নট নেসেসারিলি ফার্স্ট নোডের থেকে থাকবে। at any moment the cycle may occur in an entire linked list.
না ম্যাম, আপনি ডায়াগ্রামটা আঁকুন একটু।
বল। Yes, I have drawn the diagram. Next. Next. You are telling something, so it's not necessarily that the node, the end node is having a connection to the first one. It may be any, means if I consider the nodes this way, it may be connected to here, it may be connected to here, any. It may be anything. Its ends with means either this node end is null or this node is containing one cycle. So one cycle it is containing here, it may be connected this side also. Or if I'm considering there is no backing also, here even the way this one, then from where I do the reverse, how I can understand that from this point I need to do the reverse and all those things. I need to keep the first one that I told, that I need to keep the entire solution. I need to keep the entire solution, means entire tracking of each and individual node, and then only I can check that whether it's matching with anything previous. So do you want to tell something else? Do you want to tell something else? Okay, I'm not getting any response from you for last 2-3 minutes. I don't know where you have come. So my next question is that if the linked list is having cycle, then find the starting point. Okay. That means if a linked list is having cycle, if you need to check that, what you need to do? You need to proceed from the beginning, and then you need to traverse, and you need to using the slope. You need to identify whether there is cycle or not. That is your first job. Cycle exists, as usual, you are supposed to break. So again, first let us do the thing. You will start with S and F. Then in the next step, S will be here, F will be here. In the next step, again, S will be here and F will be here. In the next step, S will be here, F will be here, S will be here, F will be here, S here. It's continuous. This way will go on proceeding. Then S will come here. S will be here. F will be, F will be here. S will be here, and again F will come here. So this is the point when they are meeting each other. If I didn't have done anything wrong, this is their meeting point. Okay. If I didn't have done anything wrong, or you may do it in your copy. Do it in your copy and tell me whether I am right or before this point they are meeting. Say if I say this is my meeting point, so I understand that yes, cycle exists. Next, what is job? What is the starting? See, it's being done in this way that once this is meeting, call the break, and then initialize slow pointer again with the head and ask the first pointer to move only one point. So the additional code or additional steps will be rather slow pointer will be initialized with that start and slow pointer till it is equals to the first pointer. Now, so what you need to do now, you need to initialize slow pointer with the starting point and you need to check, and now in the first pointer and slow pointer both will be incremented by 1. Both will be incremented by 1. So first pointer will also go for only 1 next. slow pointer will also go for 1 next. Then what will happen? This is slow, will come here. If this is fast, then it will go here. Then it will come here. Oh, sorry, this will here. This will be now here. This will be here. Here. This way they will finally come into this point. This way, with this particular logic actually, they will come to the starting point. You just do whatever I am telling, that first increment slow pointer 1 point, fast pointer 2 point. Once they meet, stop, then assign slow pointer, means assign this line, slow pointer equals to start, and then move both the pointer 1 next or 1 position at a single step. So once that is done, you just, whenever they will become equal, you just stop there and return the position for slow pointer. And please check whether you are able to reach the point or not. Check that and tell me. Because unless until you understand the essence of the problem, no meaning whatever I am discussing here. Do that. Do that immediately and tell me whether you are able to reach with this manual process or not. Do that.
Recording stopped.
Please mute yourself. Please mute yourself. And tell me whether you are understanding both the solutions or not. Just do it manually. After the class in your time you will do, although today you have the litmus, but after that you do your practice with this code. Means, but tell me whether you are understanding the way of solution or not. So for that, just try it with this slow and fast pointer. Just draw a diagram and check. Are you understanding or are you facing any issue?
ম্যাম
Hmm?
ম্যাম স্লো আর ফার্স্ট পয়েন্টারটা মিট করার পর কি বললেন আরেকবার একটু রিপিট করুন
Once slow and first pointer meets, that means circle exists. So immediately break that loop. Obviously, you need to do that. And then assign means slow pointer reassigned with the starting of the list. And then you need to run a loop that when the slow pointer and fast pointer equal, and inside that loop increment slow pointer by one position and fast pointer by one position till they are meeting at some point. And once they will meet, then you return the slow pointer, and that would be your header. See, I have again means that diagram was clumsy enough with only one color. So you can see here that these blacks are with the finding the cycle. Even in the last time, nobody tell me that here they are meeting. Nobody bothered to tell me because no one is doing anything. So once they meet, then you need to initialize the slow pointer with the starting of the list, and then increment both pointer at a step one by one position. So once you increase one by one position, then you increase one by one point, both the pointer, and subsequently they will meet at a point, and you can see that is your beginning of the loop. So you just need to return the value of the slow pointer. Means value means just the address of the slow pointer. That is your beginning of the loop. Okay. Now, much of the things I have discussed. So you just think about the next thing, that loop is there, everything is there. You just tell me that how you can find the length of the loop. You know both the things now. How to find the loop, how to find the starting point of the loop. You just tell me that how you can just check whether means what, how you can find the length of the loop. You need to use a counter differently, but how you can use? Think about it and tell me. Think about it and tell me. Just for a minute. I'm coming just for a minute. Yes, tell your suggestion that how we can try to find the length of the loop. You need to use a counter, but where and how you can use the counter? You not need to all the time you need to find the head of the node even. That part means the second, whatever the extra part we are doing in the second question, that you may omit. Yes, please do give any suggestion. Use your brain, apply your brain. Please think something, tell something. So do not think, do not
Ma'am,
take.
can you repeat the question, ma'am?
The questions were already shared with you in, but you didn't. I'm just asking that how you can find the length of the cycle. Cycle exists, fine. How you can find means if there is a cycle, how you can find the length of the cycle. Think about the concepts. Think about it.
Hello,
And
ma'am.
yes,
Ma'am, first of all, starting point of the cycle we have get, we take that address and
even we don't get the starting point of the loop, then also we can do it. Tell me that what you are thinking with the starting point. What
okay, ma'am. First starting point address I stored in the p vector, p pointer, and the next pointer of the p I am storing in q. Okay, then while loop, I run a while loop, and I run the while loop till q is not is equal to p, and count plus plus. Then I get the
that is one point, but for that what you need to know, first you need to write a function or write a few lines of code to check where is the cycle. Then you need to write another few lines to find the head. Then you need to write another loop to find the particular disposition.
yes,
But
ma'am. Yes, ma'am.
yeah, so but here the point is, yes, your answer is almost correct. Just a little bit modification can be done in this way. For this, you no need to find the head of the loop, the starting point of the loop. The moment you find there is a loop exists, so that means slow and fast pointer both are meeting. So fix any of the pointer, maybe the slow or the fast, and use one step forward for one point. So once it is again coming back to that point, say first
Yes,
point,
ma'am.
then also you can say okay, and use a counter to count how many node it has to traverse. So
Okay,
this
ma'am.
way you can find the length. Fine.
Okay, ma'am. Basically, you say that just fixed one pointer start or
Exactly.
part.
Just fix one.
Then,
First, it's not required that you need to start with your beginning.
Yeah, ma'am, because it's in a loop, so that we can start from anywhere, right?
Exactly. That's the point. Now, the next point. Suppose now the diagram changes little bit. That two different linked list may be there. They have started from two different point, and at some particular point, they are getting merged and they become a single list. You need to find, it's not about merging of the list, it's about finding the merge point of a list. Means if I draw the diagram, it will be let's see. It's like this. You have one list here. one list here. Fine. Suppose this is your list 1, this is your list 2. You need to find, means the question says, suppose there are 2 different lists. After some time, they are getting merged and they become a single list. You need to find this merging point. So how you can get this point? Find the merging point. See, I have already given you here the 2 different length lists. So length of the list is definitely not known to you. Think about this, how we can go for any solution.
ম্যাম এখানে তো লিস্ট 1 আর লিস্ট 2 তাহলে দুটোকেই ট্রাভার্স করতে হবে। আর সাপোজ লিস্ট 1 এর জন্য পি পয়েন্টার আর লিস্ট 2 এর জন্য কিউ পয়েন্টার ইউজ করে পি লিংক আর কিউ লিংক যদি সেম অ্যাড্রেস হোল্ড করে তাহলে সেটা মার্জ পয়েন্ট।
তোমাকে প্রত্যেকবার চেক করতে হবে তাহলে। তোমার প্রত্যেকবার চেক করতে হবে, প্রত্যেকটা বার চেক করতে হবে। তাই না?
ইয়েস ম্যাম।
তোমার তো দুটো লিস্টের লেন্থ কোনটার বেশি কোনটার কম তুমি জানো না?
না।
প্রত্যেকবার নেক্সট অ্যাড্রেসে প্রত্যেক দুজনের লিস্ট নিয়ে, মানে দুটো লিস্ট আছে, প্রত্যেকের স্টার্টিং থেকে শেষ অবধি প্রত্যেকের এটা চেক করতে হবে। অনেক বেশি পরিমাণে চেকিং হবে। হতেই পারে তুমি যেভাবে বলছো সলিউশন পেতে অসুবিধা নেই, কিন্তু পয়েন্ট ইজ আর কি কিভাবে করা যেতে পারে। জাস্ট ডিফারেন্ট ওয়েজ ইউ মে থিঙ্ক। একটা সলিউশন হতে পারে, just create an array, keep all the pointers of the first list, you may short even, not required, or you may short, so that short means not with the address value, you just keep all the addresses one by one, and then for each second list of element search the shorted array. Means otherwise you need to compare in each and every step. Now you're just keeping one list, and for next list you may compare with the existing array of address. This can be a little bit easier solution. I'm not telling this is only one solution. Multiple solution exist. You may try with your own, means you may use tag even. Fine. Okay. If you are going for that, you are considering that each of the node is containing some unique value. So whenever some value is being repeated, you are considering suppose L1 list and you are going to the end because you do not know which one is merging point. So you will start from this beginning, you will go with the entire thing and you think that every value is unique. So when you start with the second list and you get the same value again, so you can stop there. That is also a solution. Or you can store the next long address in a list. If you want, you may sort even that, and then just start from another list and check whether the next pointer matches any of the addresses or not. If matches, you can say, okay, that is the margin point. Fine. So this is comparatively easy than the previous two. Now the next question is that can you find? Obviously you can find, but how you can find the middle of the list? How you can find middle of the list? Again, multiple solution exist. You can think of any of the solution and you can tell. Multiple solution may exist. Tell whatever is coming to your mind, how we can find the middle of the list. This is pretty easy. Means as per our thought process, this is pretty easy. আরে কিছু বল।
Ma'am, using length, we can find it, ma'am. And another.
By using length, you will use a counter from start to the end. Then you will get the entire list, and then you will divide it by 2. Then again from first to that many part time you will go for the next pointer, and you will find which particular node is in the middle. Yes, that can be done. Anything else? Any other solution?
Just one, give me some time.
Yeah, please think.
Using slow and fast pointer, we can also do.
How we can conclude with slow and
We're moving one pointer one step and the other one by 2 steps, and when it reaches the middle one, so
yeah, that can be better solution. So what he says that like the first cycle oriented problem where we are using this slow and fast pointer. Slow pointer is moving one step at a time and fast pointer is moving
2 steps.
at a time. So now again you can take those 2 points. Now obviously this way if we go on jumping, when the fast pointer reaches end of the list, the slow pointer definitely will be in the middle. So whatever the position of the slow pointer, you can understand that that is the middle point.
Yes.
Right.
when the fast pointer reaches the last node, and the slow one will reach to the half of
Yeah, exactly. I want to know only the half. What is the middle of the list? Without even counting the number of node, we can go in this way. And the last one, just to check whether a list length is even or odd. How we can check whether a length of the linked list is even or odd?
No, first of all, take a count variable 0 and find out the length and check whether it is modulo 2 is 0 or not.
That is okay, but can you think about some other solution? Can you think about some other solution also?
Ma'am, using for slow and fast pointer, if I use fast pointer equal to fast pointer next, then if length is odd, then always fast pointer link equal to null. If length is even, then fast pointer link not equal to null.
If length is even, then the first pointer will become null. Otherwise, it will point to the last node. Use same fast pointer and slow pointer, and this way you can get things. Okay. So this kind of things you may thought of, you may search more problem, but these are the base of that tricky problem. And another thing you may think of answering, say you know already the reversing of the linked list. Think about the reversing in a pair. Means I'm telling that you try by yourself, you just have a try. Means all these things that you are telling at this moment all are theoretical kind of. Say your list is this is your null. Fine. Reverse the linked list in pair. In pair means this will be, this is your first pair, this is your second pair. So this will be 2, 1, this will be 4, 3. Just try with yourself whether you can able to do it or not.
Ma'am, your annotation is not visible, ma'am.
Oh, sorry, share korini. Is it visible now?
Yes, ma'am.
Yeah, you need to means first line is your input. First line is your input list. They are asking that reversing pair. 1, 2 is a pair. 3, 4 is another pair. Maybe the output will be like this. Try with yourself. Just check. You know the reversing of the linked list. So just open any editor and check whether you are able to do it or not. Take 5-6 minutes time. It's 11:12. After 5 minutes, I will give you the hints how you can solve it. Then we'll go for some other topic. Before that, just try it.
Ma'am, length of the linked list always be even, na?
Consider, you may consider in that way. Otherwise, I cannot get the pair.
Okay.
I'm just coming within a minute. So, can you suggest any solution?
Man, just 1 minute, ma'am. Give me some.
Okay, fine. Whoever is giving the solution, I will stop sharing from my side, and that person maybe can share the screen to say the answer to all. Okay. I have stopped sharing, and we can. So anyone who want to share the screen can go for the, can show the solution. Yes. So those who are not understanding, for them, I'm just giving one explanation, and the person who is getting the answer, maybe he will share the screen. See, when we have done the reversing of the list, what we have done? Now our target is, we have taken 3 different pointers, and we are targeting in this way, that for the very first start of the list, we just made its next pointer to the null. But before we make the start link as a null, we take the address of the next node in some other pointer, and then we refer the start node as a next of that particular pointer. If you attended the last class and if you have practiced the reversing of the list and so, what we have done, now I know that at the end, the last node should be declared as the start and the first node linked part should be connected to the null. So for that, what we have done, now we are taking 3 pointers and mainly to keep the track of the previous node and next node, we need so many pointers. So for the very first node, we first store the address of the next node to some pointer variable. And then we are making the start link part as null. And for that second node, the next part, that is the link part, is connected to the start. This is the first step. In the next step, again, continuously we are changing the P and Q, both the points. Continuously what we are doing, we are going to the next node first, storing the address of the next node. Then we are changing the next node link to its previous node, because continuously we are keeping the track. This way, when we will reach the end, we will declare that node as start. That is simple reversing of the list. Now, when you will be asked to reverse it in pair, what you need to do? You need to check, you need to take, suppose a temporal variable, pointer variable you may take. You need to check, say in the temporal variable, take the address of the second node. That means you need to store the address of the start next in a temporal variable. Okay, that we do even in the simple program also. Then what you do? Then you need to do the start next should be temp next. Temp means what? Temp means your second node. So let me.
Can I tell my approach?
Yeah, you can share the screen even. Let me just complete it. Let me just complete it. Give me 2-3 minutes of time. Let me just complete it. So you just take your start point next pointer that must be assigned to the third node. Okay, that is your temp next. And then temp next, that is second node pointer, should be connected to the starting node. And then temp will be declared as your head. So this is a recursive method. If you understanding that how this link has to be changed, if you are understanding this, then you can make it. Here is the problem is that previously it was linked with 1 to 2 and just you need to make it 2 to 1 in from other side. But here the point is 1 to 2, the positions also need to be swapped. So 2 to 1 or this way you have to do the entire thing. Anyway, you try by yourself. Now, anything you want to say, you may share your screen and you may tell. Yes, please. Please say what you want to do or what you want to say.
Ma'am, I write in a copy, ma'am, and dry running it, ma'am, basically.
Hey, you can focus your camera if you want, or you just explain what you want to do or what you have done already.
Okay, ma'am.
Recording in progress.
Ma'am, first of all, ma'am, I take a variable, temp variable, and store the head pointer address. Then again, I take 3 more variable, first, second, and P, and all I have assigned with null, ma'am. Then I just take a while loop, and in the while loop, condition is temp not is equal to null and temp next not is equal to null, ma'am. Under the while loop, ma'am, there is I'm using if else. In the if condition, I used first is equal to null and second is equal to null, then I just assign the first is equal to temp and second is equal to temp next, and p is equal to temp next ma'am.
So this is not recursive approach, right?
This is ma'am iterative approach I'm saying ma'am.
Iterative approach. Yes, this way also you can do. Anyway, you try with your system and
Okay ma'am. Okay.
fine. So this kind of things we may get in linked list. Next, the thing that I will start, that is stack. Now let me tell you one point. See, that's a very dangerous issue that we are observing in all the panel. Every day I am telling. I don't know whether for other departments things are going on or not, but for CSC department we are doing this. Most dangerous issue is we are not getting proper answers and sometimes no answers during the mock interviews. It shows either you didn't have studied anything earlier or you people are not serious. See, I can see that as per the considerable batch stream, a very few people are doing the class. We will be not bothered if someone is not doing the class regularly or even not doing the class. But the point is, they even are not able to give the answers. I hope the students, the lot who are doing the classes, I'm not going to give you some say that, yes, why others are not doing classes. But I can say you, maybe the students who are not attending the classes, they must be your friends. So please talk to them. Please check whether how they are managing everything. They are not going to bother about your words even. That whether they, if you tell they will come and do the class, not necessarily. But the point is very simple, that if they are not doing, even they are not studying, so they will suffer. It's not about that we'll share some PPT and you will remember. This is not, please understand, please make them also understand. These are not your online semester exam.
Recording stopped.
There is no relation between the semester marks and your placement exams and interview. No relation, absolutely zero relation is there. Okay, so please talk to your friends or batchmates who are not serious even. And even in this class also, those who are present, every day I get the response from very few students. If you are not studying, if you are not involving your brain, it will be very difficult for you. Don't think that other batches grab the job, so you will get the job automatically. Those things will not happen. Every year there is a bunch of students, a total bunch, a total group. They are not placeable because they don't know anything. They had never tried. I can see here students who are not even connected to audio. So they have joined the meeting, but they are not listening. Say they are saying, "Oh, what are the rubbish things are going on?" But I am sure that if we ask anything to this particular student, we will not get the answer. I'm sure about that. Anyway, those who are present, apply your brain, apply your knowledge, everything. Involve yourself. Involve. If you do not involve yourself, no one can help you. Things are not magic, and please understand, things are not semester where 30, 40 free marks will be given. No one is there to give you free marks. And you will, for your best, things are more dangerous Because on the average, everybody is having 9 point. And inside the container, there is nothing. It's full vacant. Yesterday, I had asked, I take a mock interview of one student. That student average is 9.23, but not having the idea of any of the basics. Any means any. Not even a single definitions. This is the thing anyway. Now let me start the stack.
Recording in progress.
So whenever we are talking about linear data structure, whenever we are talking about, say, abstract data type, we come across few concepts. One of them is stack. Now, before I move into the stack, let me reiterate the concepts of the linear data structure and your abstract data type concept. See, if I consider, if you are being asked that what is data structure, the answer is very simple. That how data are organized in a memory or the mathematical models following which we can organize the data in the memory in such a way so that we can retrieve, rearrange or use or access them properly. That is the sole motive of studying the data structure. That is the main application of the data structure. One part, storing them properly in the memory, and second part, how you can access them. Okay. Now, for storing them, we need different format. Not the format of the data. We are not talking about the format of the data. What we are talking about? We are talking about that in which way, in which model you can keep the data in the memory. The particular data structure is nothing but a model. Today you are using this model term every day when you are studying your machine learning and that machine learning domain related papers. Okay. So this means that whenever we are going to deal with this, I need to store the data properly. Now, why the properly is required? So that whenever you need to access, you can access it easily. Easily means what? In least amount of time. Now, accessing may be of any purpose, maybe for storing, maybe for changing the data, modifying the data, anything. Now, what about the abstract data type? The abstract data type, obviously, first of all, is not something inbuilt. We consider that when we have studied any of the basic languages or the basic things of any programming language, we find what? We find there is some primitive data type and some non-primitive data type. Now, non-primitive data types are the category of user-defined data type. So, in the abstract data type also, what we will get, now in case of ADT, which is full form of abstract data type, see why I'm emphasizing these two definitions, the data structure and the ADT. Again, these are the very common question in the interview. You write or not write data structure and algorithms in your CV, you may be asked directly, what is data structure? What we do there? In the definition itself, it says, yes? Are you telling something? Okay, fine. So abstract data type says, first of all, it's a user-defined data type. Okay. Means no inbuilt, nothing is inbuilt. You will never get some ADT which is inbuilt already in the system. Second, during defining, you tell the system that what kind of data you are going to store and what are the different operations can be done. Means what are the different mathematical or logical operations can be done, how those data can be accessed for insertion, deletion, or updation purpose. If you satisfy all these things for a user defined data type, then only you call it as a abstract data type. Why abstract now, and what is the significance of the term abstract? Always abstract term means you can feel it, but you cannot see it. There may not be any real physical existence. You cannot see it. Okay? Say abstract. It's an abstract concept. See, if you can see, there is means abstract means which do not have any kind of physical existence, but the concept is there. Based on that, many other things are going on. So for kind of user defined data type, where you specify what kind of data is going to be stored there, how those data, and all the manipulation functions, means how those data can be accessed for insertion, deletion, or doing some any kind of manipulation. If those also being specified by you means the user, then you can say, then you can call that particular data type as ADT or abstract data type. Stack is one kind of ADT. Stack is one kind of ADT. Now, what we generally understand with the concept of stack. Now you can see the slide. These are actually let me talk to these people. Yes, Trina Sharkar, are you there in the meeting? Please respond.
Yes, ma'am.
Why you are writing your attendance in the chat? That means maximum time you are not here in the meeting. I'm telling repeatedly that no need to write the attendance in the chat. We take the attendance only from the Zoom report, nothing else.
Okay, ma'am, I joined late. Sorry.
You don't know the rule. Anyway, so this is your concept of stack, where, or the example, see the set of plates, they are being placed one over another. Set of books, they are also being placed one over another. Okay, so this is your example of the stack. Means what do we understand in real life? What we understand by the term stack? That some set of elements are there and where each of them are being placed one by one. Now, if I consider about simple numbers or data, how things can be there? I will place one by one data and things will become stack. I will take an array and insert one by one number and that will become stack. Unfortunately, no. That is not the essence. What is the essence from this picture? From this picture, you can get the essence that stack means what? Not only piling up the things in this sequential manner in one by one. Rather, it says that if I need to access this yellow book, I cannot take it by snatching it away from here. I need to take first this red or pink, whatever you say, this colored book. First you need to take this book, then only you can get the yellow book. Say if you want to take this green book, the sap green. Okay, if you want to take this particular book, then you need to come out, you need to take out this pink book first, then the yellow book, then maybe it's navy blue, so navy blue book, then only you will get this green book. This is the essence of the stack, that you cannot access, the stack operations do not allow you to access the elements directly. But that doesn't mean if I consider it as a normal array, the array becomes unaccessible. No, no such thing can be happen, because you cannot give that level of protection. In normal C program, you cannot, a normal algorithm, you cannot give that kind of protection. The thing is, as per the concept of the stack, if you are using the array to implement the concept of stack, then you are not supposed to access any of the elements from any position. You are supposed to access the element from only one end, from only this end. And this end is your top. You can see here that you need to remove the topmost element, then only you can get the access of the second topmost element. If you remove topmost and second topmost element, then only you will get the access to the third element, and so on. So this is the concept. So what we can call as a stack? Now stack, first of all, it's a linear data structure. Oh yes, I need to tell one point again about the linear data structure. That is, linear data structure doesn't mean they are maintained in some straight line or linear order. No, no such things. Means those are true, but the main point in the definition is they maintain the principle of adjacency. Any linear data structure maintain the principle of adjacency. What does it mean by the principle of adjacency? Now, one element is adjacent to its previous element and next element. Obviously, the condition is if both the elements exist. It will not maintain any kind of hierarchical relationship. It maintains just, they are being, if you are trying to place them in the memory, they are maintaining the adjacency in their position. So that is your principle of adjacency. And in case of linear data structure, every element maintain this principle of adjacency. One element is adjacent to its previous and the next element. All time, for all the element, this is true. It's not like that for some element it is true and for some element it's not true. It's not the case. Okay. Now, so what are the things we can do with the stack? Now, push and pop. Yes, push means to keep the things after the last point. What is the last point? Now, that is top. And pop means just taking out the things. Now, if you can see the examples, you understand that you need to pop it out. Means you need to remove something. You cannot snatch it away from anywhere. You need to remove it from the top even. So, the element which is present in the top, that is the element which is kept there at the end. In a stack of book or in a stack of plate, the plate that you are taking from the top, that is actually being kept there at the
আমি সবজির কথা বলছি ডাল দিয়ে বলি না আলু মসুরি আমি তো আলু মসুরি না তুই এমনি ডাল করবি ডালে হালকা করে কাঁচা পেঁয়াজ দিয়ে দিবি সেটা মুড়ি দিয়ে মাখিয়ে খাবি হেভি লাগে লঙ্কা কাঁচা লঙ্কা
মানছি তোরা রান্না করছিস, রান্নার বদলে এত ঝগড়াঝাটি করছিস কেন? ওহ, যত ভাবি যে নর্মাল প্রসেসে ক্লাস চলবে, না, হঠাৎ করে শুরু করে ফেললি সে একটা যুদ্ধক্ষেত্রে ডাল ভাত রান্না হচ্ছে। ঠিক আছে, আমি মানছি তোরা হয়তো মেসে থাকিস, রান্না করতে হয় নিজেদেরকে, তাহলে এরকম স্ট্যাক বলা চলছে, হঠাৎ করে পেঁয়াজ ডাল নিয়ে একদম তেড়ে ফেড়ে চলে এলি। নিজেকে মিউট রাখবি তো। তা নাহলে তো কখনো নিজেদের পার্সোনাল কথা অব্দি চলে আসবে। বুঝতে হবে তো, আজকে ক্লাসে করছিস, আমি দুটো কথা বলবো, বন্ধুরা হাসাহাসি করবে, 6 মাস পর তো অফিসের মিটিং এ করে ফেলবি এইসব। 6 মাস পর তো অফিসের মিটিং এ এগুলো করে ফেলবি, ভাবতেও পারবি না যে অফিসের মিটিং এর টাইমে কোনো একটা ভুল ওয়ার্ড বলে ফেললে কি ঘটতে পারে। ভাবতেও পারবি না যে যত বড়ই মানুষ হোক, কোনো অফিসিয়াল মিটিং এর টাইমে যদি কেউ ভুলভাল বলে ফেলে তার কি পেনাল্টি হতে পারে সেটা ভেবে দেখবি, আর ভেবে দেখতে না পারলে গুগল করে দেখে নিস, সিনিয়রদেরও জিজ্ঞেস করতে পারিস। শিখতে হবে তো কোন জিনিসটা পার্সোনাল আর কোনটা প্রফেশনাল, শিখতে হবে, এটা শেখার বিষয়। তোর পার্সোনালি একটা মানুষকে, ধর আমাকেই তোর একদম পছন্দ নাই হতে পারে, কিন্তু আপাতত যে কথাগুলো বলছি সেগুলো তোরা ভুলে গেছিস, সেকেন্ড ইয়ারে পড়েছিলি অনেকদিন আগে, কেউ ফার্স্ট ইয়ারে পড়েছিলি শুধু, সেটা তো শোনার প্রয়োজন না।
হ্যালো ম্যাম। ম্যাম সরি ম্যাম, ওটা ভুল করে আমার করে দিয়েছিল একজন ম্যাম, আমি ইন্টেনশনালি করিনি ম্যাম, সরি ম্যাম।
ঠিক আছে, বুঝতে পেরেছি, মিউট করে নাও, নিজেকে মিউট করে রাখো, শুধু প্রশ্ন করার সময় আনমিউট করবে, তাহলে আর এই গন্ডগোল গুলো হবে না।
ওকে ম্যাম।
মানে এই যে আজকে আমরা ভুলটা শুনতে পাচ্ছি, এটা অফিস হলে আর পাবি না। একটা অফিসিয়াল মিটিং এ যদি এটা হয়, তোকে চিরতরে সেখান থেকে রিমুভ করে দিল, আর তুই মিটিং এমনি তো জুম থেকে তোকে যদি রিমুভ করে দিই তুই আর জয়েন করতে পারবি না। জানিস নিশ্চয়ই আগের সেমিস্টারে দেবকুমার স্যার একজন না দুজনকে রিমুভ করে দিয়েছিল, তারা আর পরীক্ষার লিঙ্কে ঢুকতে পারছিল না। ঠিক আছে, বুঝতে হবে, শিখতে হবে জিনিসগুলো।
ম্যাম আর হবে না ম্যাম, সরি ম্যাম।
মিউট করো নিজেকে, ফাইন। So you have nothing to memorize. Always, whenever we are talking about the stack, think in this way: the way we are keeping the plates, or the way we are getting the plates in any kind of, say you are going for a buffet dinner, or say in any occasion where the buffet things are going on and plates are being piled up there. So which plate you can take first? Now the plate that is being placed at the end, the topmost thing, is something which is actually being placed at the end. So that means whenever you are taking out something from the list, that is nothing but your last in, first out. So the element that is entered last is coming out as the first element. Okay, fine. What else operation? So push, which is similar to the insertion, pop, which is similar to the deletion. Another operation is there, which is called peek. What does it mean, or what it do? Now it will show the data value which is present in the top of the list, but it do not remove it. In case of pop function, what happened? Now it call the pop function and it will return you the value by deleting it from the list if you call the pop function. And in case of pick, you are just supposed to show the topmost element, not deleting it from the stack. Now, is this push, pop, or the pick, is all these are inbuilt function? Absolutely not. Again, these are the popular term that we use with the stack. No inbuilt function is there. There is no different library or package or anything named stack where this push, pop, pick, everything exists. No, nothing like that. I'm talking about the basic way, the C way. I'm talking about what exists there. Okay. I'm not talking about those Python functions that where you call this kind of thing and something is coming out or anything. No, I'm not talking about. I'm considering the basic concept that how these things are there. Okay. So stack means it will look like that. Performance, last in, first out. Now, that means what? That if I declare something as stack, it will perform last in, first out? No, it's an ADT. So you have to ensure with your own code that yes, it's a stack. You cannot consider it from anywhere. Now, whenever you are inserting the elements or whenever you are considering the stack implementation, you can implement it either using array or using the linked list. Okay. So if you are going for the array implementation, then obviously array is always of limited area, limited space, and obviously there can be always a chance that then what will be there? Then you will find that if it is full, then there will be overflow situation. If it is not, if it is a linked list, generally there is no chance that there will be any overflow. Okay. You will gradually understand. These are the things that I have already explained. Now, so in the first we will discuss with the concept of array. Now, whenever we discuss the concept of stack, we generally think that that is a vertical list. Before I go for the coding part, let me say one thing, that there is nothing vertical list exists in the memory. Everything is horizontal. So it will be left to right. It's a simple array. While I'm using it as a stack, I need to impose some method, some restriction, so that the array can behave like a stack. So just it's an example of push and pop, how things are going on. Now see, this is say your array. So the elements of top initially, the top variable always points to the last element inserted, last inserted element. Top will always point to the last inserted element. As I'm implementing it using the stack, the index numbers are 0 to max minus 1. So suppose you are inserting 5. So the moment you insert a single element, see the top is getting changed to 0. Top is getting changed to 0. Okay. So first element inserted, then the top element, top value is 0. 0 is the index. So top is indicating what? Index position. Yes, it's pointing to the, it will give you the index position of the last inserted element. Now it was an empty list. The first element or the last element, what you can say for this instant, that is 5 inserted at the first position. Okay. So this way, every time one element will be inserted, the top will be incremented, right? So what I need to do if I want to write the algorithm or the code, see, this is max minus 1. So that means this way, once top will reach this place, you can say that, okay, top has reached this place, so there is no space at all. So then stack is full and it will lead to the overflow condition. If it is full, then nothing can be done. If it is not full, then you can increment the top. Now you say that why the top incrementation is done fast. The reason is what? Because top is initialized with -1. So first increment it by 1, it will become 0 or anything. So increment the top variable first and then you assign it. Then you assign it to here. Similarly, if I want to do the pop, if top is pointing to the 0, or you can say the -1, whatever, then it's an underflow. It's an underflow situation. And to pop, you just need to take the element in some variable. A top, A is the name of the array, and then you need to just decrement it. You just need to decrement it. Okay. If you want to show all the elements of the stack, then from top to the 0th level, whatever the elements are there, you just need to print them. From the top till the beginning, that is the 0th location, you can do the printing. So this is all about the basic things of the stack. We will discuss elaborately, and there are many things. It's not about what is stack and what are the operations. It's not limited to this. There are types of stack and implementation and everything we will discuss in the next class. As of now, I'm stopping here because I think sir is waiting here. So let me
Recording stopped.
check this.
Hello, ma'am.
হ্যাঁ বলো।
Ma'am, can you repeat the editing? I am note downing it.
Abstract data type, first of all, it's user defined. Next point, user means the you, who is telling what kind of data is going to be stored, how the data is to be stored, and what are the different operations to be done with those data.
Okay, ma'am.
Fine. This entire thing gives you means the data and the functions or the operations that you can do if you are telling everything that makes that create the entire concept of the edit. Okay. Sir, I have made you co-host. Over to you, sir. Sir, you can continue now. Suppose, sir, I have made you the co-host as it's already 12.